And again, as I just mentioned, here we're going to use a Moore Coulomb model. So remember, this line indicates the Moore failure envelope, and that was determined by, we went to the lab and we tested rock at different confining pressures. We made all these circles, and then the line tangent to those circles we approximated as a straight line, and that's our Moore Coulomb or our Moore failure model, right? And it's a two-parameter model. That, remember, it has basically a cohesion or a cohesive strength and an internal friction. The internal friction determines the slope of this line, right? So we go to the lab, we do some tests, we define this Moore failure envelope, and then with that, we can look at we can compute the actual stresses and plot them against our Moore failure line, and basically any stress state that's over here is going to be beyond the strength of the rock and therefore cause the rock to fail. Okay? So if we plot that, if we plot where those stresses occur on our wellbore, it can be indicated by this line. So anywhere inside this line corresponds to a stress state, mainly hoop stresses, to a stress state that exceeds the Moore failure envelope and therefore will cause the wellbore to be unstable, cause breakouts. Okay? So then what's plotted actually here is if you remember from the Moore model, there's this parameter CO. So it's the value of that CO parameter that is needed to have a stable wellbore. So again, this figure is in color in the book. If you want to take a look, you'll be able to see. But basically, it just shows that, in these areas where there's a high CO, then the rock needs to be stronger in that area to avoid having wellbore instability. Yeah.
How far, can we determine how far the breakout will go across for breakout?
Yeah, well, I mean, these lines really indicate it. Yeah, so anywhere that you've exceeded the strength of the rock, if your failure model is good, right? Remember, they're just models, and they may not represent the strength of the rock perfectly. But if the failure model is good, and we can add sophistication to get better and better failure models, then we can determine exactly how deep into the rock it'll go. Of course, you also have to remember that once you have some breakout, now your wellbore is not perfect circle anymore, right? So the Kirsch solution is not exactly accurate anymore either. So these are just models that help us design wellbores. Ultimately, what we'll want to do is add some safety factor in there, right? If we could. We'll talk about one way you can stabilize a wellbore, but unfortunately, there's not a lot of room to add safety factor, right? So when I say safety factor, it would be great if you could just avoid, if through wellbore stabilization, which is essentially going to be with mud weight, right? If you could just increase the mud weight as high as you want, and such that you're two times away, twice as far away from the failure envelope, right? That would be some safety factor. Where the maximal stress is half, right? That would be a safety factor of 2. Maximal stress is half the stress of the failure envelope. Unfortunately, we can't do that, and I'll talk about why. There's a small window, actually.